you must have heard of this row store versus column store. And I want to ask the class, is there any difference? Or if there's a difference, what's the difference between these two different architecture? So we will look at maybe a diagram to learn more about each. And this is row store, and this is column store. I want the class to take a very close look at these two different architectures, row store, column store. Both are widely used in industry and widely researched in the academic community as well. We're going to pause here for a few seconds. What do you think? So you see, with the row store, when the data is stored in storage and when the data is read into the memory, the data is processed record by record. You see, we have product ID for each product. We have order date and the cost, right? So each record has 3 columns. If we have row store, the data is stored on hard drive in storage like this. When the data is read into the memory, and this is the format as well. But if we have column store on hard drive, the data is stored column by column. So product ID, this column, data for this column is stored together. And data for order date is stored together. And then cost, right? And these are different architectures. What are the ramifications? I want you to think, what is row store good for? What is column store good for? Think about how we work with data, right?
Fetching data for a particular product ID will be difficult in column store.
So think about the data operations. So how many common types of data operations do we have? For example, you will process orders, right? So you retrieve an order or you create an order. You once you retrieve an order, if you want to change something or you retrieve a customer's profile, you need to change something, then you will work with usually the entire record, right? For example, you may need to bring up this record by product ID, and then you will update whatever the cost, whatever, just think about some operations we need to do. So if we want to update data, usually we need more than just one column. Okay, so row store is very good to support data changes or you want to create a new record or you want to update a record and those things. Okay. On the other hand, column store is very good for supporting reporting, right? So when we do data analysis, when we do reporting, usually what is our primary focus? You think about different scenarios, right? For example, you may want to know, can you think of some examples? Our data is very simple, but let's see whether we can. Using this very simple data, can you think of some examples for reporting requirements?
Professor, we can calculate aggregation. We can do aggregation for like cost.
Cost, right? Total cost, right? Excellent. And then the dates in which we have a sale, right?
Yes, Professor.
And things like that, right? So when you do data aggregation, when you do reporting, usually we focus on specific columns or specific column. So column store is very good for supporting reporting or data warehousing. Row store is very good for supporting applications such as order processing or your customer care, those types of applications, right? So our conclusion is row store is more efficient for update or processing transactions. Column store is more efficient for query or reporting. Why? I think that's a fundamental question. Why? Why are they more efficient? Why is one more efficient than the other for some type of use cases? Why? Think about reporting, right? If we do reporting and you want to find out the total cost, your primary interest is in this column. Your data is stored on hard drive by column. So for your specific request, you want to calculate the total cost, you just bring data for this column into the memory. Because on hard drive, data for this column, for the cost column is stored together. So you just need to go to maybe one location to get all the data you need. And then once the data is brought into the memory, because the data must be in the memory for processing, right? Because you have only the cost numbers, so you can store more data, more relevant data in the memory. That will improve the query performance as well. So two primary reasons. Number one, it takes the database management system much less time to get the data you need for reporting, for a specific query, for creating a specific report. Number two, you can bring more relevant data into the memory at a time. So this combination will speed up your reporting process, your query performance, sometimes by tens of times, 10, 20 times easily. Okay, on the other hand, if you want to update the data your customer calls in, your customers calls in, they want to change the address or whatever, right? You want to bring up the record for that specific customer. You want all columns for that customer to be brought into the memory. Because if you store data using this row store, all data for a customer is stored together. So your database management system just goes to one location to get all the data you need. And then because you just bring in relevant data, you can bring more relevant data for updates in the memory, right? Because data must be in the memory for processing. And if you want to update certain records, and when you update the record, you need multiple columns, then you will just bring those complete records into the memory. If you use column store for updates, the data will be stored by column, not by record, not by a row. Then you may need to go to more locations to get the data you need. Going to more locations for the database management system to get the data you need means it takes longer, right? Performance may degrade. So that's the reason why row store is more efficient for updates, update a record. And column store is more efficient for reporting or for query. And in your textbook, the advanced data management, the authors covered some compression algorithms for the column store for this. Column store, okay. One example was round length encoding. You look at the raw data, you have 3205, and the algorithm will compress 3 records into one record, one row. So 205 starts at location 1. There are 3 occurrences of 205. You see, just look at this, how the raw data is compressed. If you can do this type of compression, that means you can bring even more data that you want, more relevant data into the memory. You can get more data into the memory that will significantly improve your query performance, because you cannot use data on hard drive directly. Data must be read into the memory for processing. So this will help the performance, query performance of the column store as well. So column store has been used with NoSQL database management systems for a long time. Okay, so NoSQL database management systems tend to use column store, quite a few of them. But this column store architecture has been adopted by relational databases as well. For example, with SQL Server or in Azure, the new SQL, you can create column store index. But keep in mind, column store is good to support queries. So for NoSQL, for relational databases, you can only use column store for reporting operation. You cannot use column store indexes or whatever for processing transactions. I think this is also very important. And keep in mind, with the column store, if we use SQL Server, if we use column store for reporting instead of the traditional row store, the query performance may be improved by 10, 20 times. Okay, there are enough statistics, there's enough data to prove that.